Ni2O3. The chemical name of this compound is iron 3 oxide. Now, are you one of those who are having a hard time figuring out the charged metal cation? Confused as to whether it's iron 2 plus or iron 3 plus? Well, this video will help you ease this puzzlement. Hello everyone, and again welcome to my channel. For today's video, we're gonna be talking about how to name binary ionic compound with variable charge metals or ionic compounds involving transition metals. To maximize what you can learn from this video, I invite you to watch it from here until the end. And if you're new to my channel, please don't forget to subscribe and ring the notification bell for you to be updated of my latest video. So, let's not make this long and please join me in my discussion. Tara! Transition metals. Transition metals are the metal elements found in group 3 to group 12 of the periodic table, or the metal elements that you can see inside of the rectangle. Iron, cobalt, nickel, copper, silver, and gold are some of the common and notable transition metals. Unlike the metals in Group 1 and Group 2 of the periodic table, transition metals can make a wide variety of ions with different charges. Iron, for example, can form two different types of ions: iron with a 2 plus charge and iron with a 3 plus charge. But there are transition metals that can form only one type of ion. We have silver, which can only form an ion with a 1 plus charge. We have also zinc, which can only form an ion with a 2 plus charge, and cadmium, which can also form an ion with a 2 plus charge. But take note that majority of transition metals form more than two types of ions of different charges. Before we go to the naming of binary ionic compounds with variable charge metals, allow me first to discuss some key points that will help us in understanding the topic. First point, most cations and anions can combine to form neutral compounds. Now, what do we mean by neutral compound? A compound is said to be neutral if the total positive charge is equal to the total negative charge. Let us say, for example, this ionic compound, NaCl. NaCl is an electrically neutral ionic compound because sodium, our cation, has a charge of 1 plus, and since there is only one atom of sodium present, that means that the total positive charge is equal to 1 plus. And chlorine, our anion, has a charge of 1 minus. And since there is only one atom of chlorine present in this compound, that gives off a total negative charge of 1 minus. Take note that the net charge of an ionic compound must be 0, and for a compound to have a 0 net charge, it has to be electrically neutral. Just like this example, since this ionic compound is a neutral compound, therefore the net charge of this compound is 0. Another point that I would like to emphasize when naming ionic compounds involving transition metals is that the cation retains the same name as the element, and the anion's name is similar to elemental name, but ending should be replaced with IDE. Just take for example this compound, Ni2O3. Ni is our cation, and Ni is a chemical symbol of the element nickel. And to name this compound, Ni will still be nickel. And O is our anion. And O is the chemical symbol of the element oxygen. And what do we need to do? We have to replace the ending with the letters IDE. O will become oxide. So the correct name of this compound Ni2O3 is nickel 3 oxide. Now why there is a Roman numeral 3? This will be our next point. When naming ionic compounds involving transition metals, the charge of the metal cation has to be indicated by a Roman numeral in parentheses after its name. This is because transition metals form ions with different charges. Let's say for example Ni2O3, or this is nickel 3 oxide. The Roman numeral 3 indicates that nickel is an ion with a 3 plus charge. Again, in naming ionic compounds involving transition metals, we have to indicate the charge of the metal cation using a Roman numeral. Let us start naming binary ionic compound with this example, FeCl2. To correctly name this compound, we have to follow these steps. First, we have to identify the cation and the anion. In any ionic compound just like this, it is the cation that is written first and followed by the anion. This means that Fe is our cation and Cl is our anion. And Fe is a transition metal that forms two different ions, Fe with a 2 plus charge and Fe with a 3 plus charge. And Cl is our nonmetal anion which has a 1 minus charge. Later, we'll find out which of these ions of Fe is present in this compound, FeCl2. In step 2, we have to name the cation by its element name. Include the Roman numeral to indicate the oxidation number or charge in the metal cation. And since our cation is Fe, and Fe is a chemical symbol of what element? Right, it's a chemical symbol of the element iron. And we have to indicate the charge. But we don't know the charge yet. We don't know if this is iron 2 or iron 3. To determine the charge of iron, we have to start with the ion with a definite charge, and that is Cl. Cl has a 1 minus charge, and since there is a substitute present in the compound, this means that there are two atoms of Cl present in the compound. 1, 2. So, the total negative charge is 2 minus. And since there is only one atom of iron present in a compound, this means that iron should be carrying a charge that is equal to the total charge of the anion. Therefore, the charge of iron is, right, it's 2 plus. To have a total positive charge of 2 plus, that will balance out to the total charge of the anion, making this compound an electrically neutral compound. This 2 plus charge of iron has to be indicated in the name of the compound using a Roman numeral. So, this will become iron 2. Let us now move on to step 3. In step 3, we have to name the anion by taking the root name of the element and add the letters IDE. Our anion is Cl, and Cl is a chemical symbol of what element? Right, it's a chemical symbol of the element chlorine. And to look for the root of chlorine, here is chlorine,
The root of chlorine is chlor, that's CHLOR. And add the letters IDE, making it chlor plus IDE. And finally, we have to write the names of the compound by combining the names of the ions. For our cation, the name is iron 2, and our anion's name is chloride. So, the correct name of this formula FeCl2 is right. It's iron 2 chloride.
Let us have another example. CO2S3. To correctly name this compound, again, we have to follow these steps. Step 1, we have to identify the cation and the anion. In any ionic compound just like this, it's always the cation that's written first and followed by the anion. So, CO is our cation and S is our anion. CO forms two different ions, CO with a 2 plus charge and CO with a 3 plus charge. And S, our anion, has a 2 minus charge. And we're done with step 1. Let's move on to step 2. In step 2, we have to name the cation by its element name. Include the Roman numeral to indicate the oxidation number or charge of the metal cation. Now our cation is CO, and CO is a chemical symbol of what element? Right, it's a chemical symbol of the element cobalt. But we don't know yet if what is the charge of cobalt. Is it 2 plus or 3 plus? To determine the charge of the cobalt, we have to start with the ion with a known charge, and that is S, because S has a fixed charge of 2 minus. And since there is a subscript 3 here, that means that there are 3 atoms of S present in this compound. 1, 2, 3, and each of these 3 atoms has a 2 minus charge, making a total of 6 minus charge. And since there is a subscript here, this means to say that there are 2 atoms of cobalt present in this compound. And for these 2 atoms of cobalt to have a total charge that is equal to the total charge of the anion, these 2 atoms must be carrying a charge of, right, each of them must be carrying a charge of 3 plus charge. 3 plus, and another 3 plus charge, making a total of 6 plus charge. And this 6 plus charge balance out with the total negative charge of our anion, making this compound CO2S3 a neutral compound. So then, the charge of cobalt is 3 plus, and we have to indicate this using a Roman numeral in naming this compound. So cobalt 3. So the name of our cation is cobalt 3. And let's proceed to step 3. In step 3, we have to name the anion by taking the root name of the element and add the letters IDE. Our anion is S, and S is a chemical symbol of what element? Right, it's a chemical symbol of the element sulfur. And to look for the root of sulfur, we have here a table. Here is sulfur, and the root is salt, that is SULF. So, we have to add the letters IDE, that is salt plus IDE. Finally, we have to write the name of compound by combining the names of the ions. Our cation's name is cobalt 3, and our anion's name is sulfide. So, the correct name of this chemical compound is, right, it's cobalt 3 sulfide. Let us have another example. PbS2. Again,
To correctly name this compound, we have to follow these steps. First step, we have to identify the cation and the anion. As what I have said in ionic compound, it's the cation that is written first and followed by the anion. So Pb is our cation and S is our anion. And Pb forms two different ions. Pb with a 2 plus charge and Pb with a 4 plus charge. And our anion is S, and S is or has a 2 minus charge. We're done with step 1. Let's proceed to step 2. In step 2, we have to name the cation by its element name. Include the Roman numeral to indicate the oxidation number or charge of the metal cation. Pb is our cation and Pb is a chemical symbol of what element? Right, it's a chemical symbol of the element lead. So then, we don't know which lead is present in this compound. Is it lead with a 2 plus charge or lead with a 4 plus charge? To determine the charge of our cation, which is lead, we have to start with the ion with a known or definite charge, and that is S, because S has a fixed charge of 2 minus. And since there is a subscript 2 here, that means to say that there are 2 atoms of S present in this compound. 1, 2, making a total of 4 minus charge. And since there is only one atom of lead present in the compound, this means to say that this atom of lead should be carrying a charge that is equal to the total charge of the anion, which is 4 minus. So then, what is the charge of lead? Right, it has a charge of 4 plus to have a total positive charge of 4 plus, making this compound PbS2 a neutral compound. So then the charge of Pb or lead is 4 plus, and we have to indicate this in the name of the cation. So the name of the cation in this compound PbS2 is lead 4, and the 4 must be in a Roman numeral. Right, so we're done with step number 2. Let's proceed to step number 3. We have to name the anion by taking the root name of the element and add the letters IDE. Our anion is S, and S is a chemical symbol of what element? Right, it's a chemical symbol of the element sulfur. And let's look for the root of sulfur. Here is sulfur, and the root of sulfur is Sol. That is SULF. And we have to add the letters IDE, making it Sol plus IDE. And finally, we have to write the name of the compound by combining the names of the ions. For our cation, that's lead 4, and for our anion, that's sulfide. So, the name of this compound, PbS2, is right, it's lead 4 sulfide.
Let us now check your understanding. Which of the following do you think is the correct name of this formula? CuCl. And if you answered copper 1 chloride, well done! Which of the following do you think is the chemical name of this formula? NiBr2. And if you answered nickel 2 bromide, bravo! Which of the following do you think is the correct name of this formula? PbS2. And And if your answer is lead 4 sulfide, you're great! Which of the following is the correct name of this formula? FeO. And if your answer is iron 2 oxide, keep it up! Which of the following do you think is the chemical name of this formula? Hg3p2. And if your answer is mercury 2 phosphide, well, congratulations!
Really hard.